programs. Objectives. At the end of this video, you will be able to connect microcontroller-based Arduino board to computer and execute sample programs. To execute simple programs. Let us collect the equipments and materials required to do this practical. Laptop or PC. Arduino Uno board with USB connector. Breadboard 1 number. LED 5mm 1 number. Resistor 100 ohms 1 number. Let us discuss microcontroller based Arduino boards. Arduino boards are microcontroller-based development boards that are widely used for prototyping and building electronics projects. The Arduino platform provides an easy-to-use hardware and software environment for beginners and professionals alike to create interactive projects. Microcontroller. Arduino boards are built around microcontrollers, which are small integrated circuits that contain a processor, memory, and input or output peripherals. Arduino IDE. The Arduino Integrated Development Environment (IDE) is a software application used to write, compile, and upload code to Arduino boards. It provides a simplified programming environment based on the wiring programming language, which is derived from C, C++. Arduino boards typically feature multiple digital and analog input or output pins that can be used to interface with sensors, actuators, displays, and other electronic components. Arduino boards are versatile and can be used for a wide range of applications, including robotics, home automation, Internet of Things, IoT projects, wearable technology, interactive art installations, and educational activities. Task 1. Installing Arduino software on the PC. Step 1. Go to the official Arduino website at www.arduino.com and download the Arduino IDE for your operating system, Windows, Mac OS, or Linux. Step 2. Once the download is complete, locate the downloaded file and run the installer. Step 3. Follow the installation wizard. The installation wizard will guide you through the installation process. Follow the on-screen instructions and you can usually stick with the default settings unless you have specific preferences. Step 4. Once the installation is complete, you should see a shortcut for the Arduino IDE on your desktop. Step 5. Double-click on the Arduino IDE shortcut to open the application. Task 2. Connect microcontroller-based Arduino board to computer. Step 1. Ensure you have your Arduino board. Example: Arduino Uno, Arduino Nano, Arduino Mega, a USB cable, usually USB-A to USB-B, and your computer. Step 2. Plug one end of the USB cable into the USB port on your Arduino board. The port is typically located near the power jack or on the edge of the board. Then connect the other end of the USB cable to an available USB port on your computer. Step 3. After connecting the Arduino board to your computer, you may need to check if it's recognized. On Windows, you can open Device Manager and look for the Arduino under the Ports, COM and LPT section. Step 4. Before you start coding, you might need to configure the Arduino IDE to work with your specific Arduino board. Go to Tools, Board and select your Arduino board from the list. Step 5. Insert the LED into the breadboard. Ensure the longer leg anode is connected to one row and the shorter leg cathode is connected to another row. Step 6. Insert one end of the resistor into the same row as the shorter leg of the LED cathode. Connect the other end of the resistor to another row on the breadboard. Step 7. Use a jumper wire to connect the row where the resistor's other end is inserted to any GND ground pin or the Arduino board. It's common to use the GND pin next to pin 13. Step 8. Use a jumper wire to connect the longer leg of the LED anode to a digital pin on the Arduino board. Let's use pin 13. Task 3. Execute simple programs. Step 1. In the Arduino IDE, go to File, New. to create a new sketch. This will open a new blank sketch window where you can write your code. Step 2. In the sketch window, you can write your Arduino code using the Arduino programming language, which is based on C, C++. If you are new to Arduino programming, you can start with simple programs. Step 3. Here's a basic example of a blink sketch which blinks an LED connected to pin 13 on the Arduino board. Once you have written your code, save your sketch by going to File, Save or pressing Ctrl+S. Step 4. Click the Upload button to upload the sketch to the Arduino board. Step 5. Click the Upload button, right arrow icon or go to Sketch Upload to upload the code to your Arduino board. The Arduino IDE will compile your sketch and transfer it to the connected Arduino board. Step 6. During the upload process, you will see status messages in the Arduino IDE's console at the bottom. Once the upload is complete, you'll see a Done Uploading message. Step 7. Once the sketch is uploaded, your Arduino board will execute the code. You should see the LED connected to the specified pin, blinking on and off according to the code. Recap. In this video, we have discussed how to connect microcontroller-based Arduino board to computer and execute sample programs. To execute simple programs. Thanks for watching. Hi everyone, in today's video, let us learn how to flash the various brands of cell phones or smartphones. Objectives. At the end of this video, you will be able to identify the flashing tools, perform a flashing process, flash the various brands of cell phones and smartphones. Let us collect the tools and equipment required to do this practical. Cell phone or smartphone with SD card, 1 number. Data connection to the cell phone, 1 number. Desktop computer or laptop, 1 number. Let us discuss the flashing process on a smartphone. Flashing typically refers to the process of installing or updating the operating system or firmware on the device. This can involve replacing the existing operating system with a newer version, installing a custom ROM, customized version of the operating system, or applying patches and updates provided by the manufacturer or third-party developers. Task 1. Identify the flashing tools. Let us discuss flashing tools. A flashing tool for smartphones is a software application or utility designed to facilitate the process of flashing firmware, custom ROMs, recovery images, and other software components onto a smartphone or tablet device. Number 1. Odin. Odin is a popular flashing tool specifically designed for Samsung Android devices. It's commonly used to flash firmware, custom ROMs, kernels, and recovery images on Samsung smartphones and tablets. Number 2. SP Flash Tool. The SP Flash Tool is primarily used for MediaTek-powered Android devices. It allows users to flash firmware, custom ROMs, recovery images, and more on smartphones and tablets with MediaTek chipsets. Number 3. Fast Boot or ADB. Fast Boot or ADB, Android Debug Bridge, are command line tools included in the Android SDK software development kit. They are commonly used for flashing Google Pixel devices and other Android devices that support Fast Boot mode. Fast Boot is particularly useful for unlocking the bootloader, flashing partitions, and performing other low-level tasks. Number 4. Mi Flash Tool. Mi Flash Tool is developed by Xiaomi for flashing firmware on Xiaomi Mi smartphones and tablets. It supports flashing both stock ROMs and custom ROMs, as well as unbricking devices and restoring stock firmware. Number 5. SPD Flash Tool. SPD, Spread Drum Flash Tool. Flash Tool is used for flashing firmware on smartphones and feature phones powered by Spread Drum SPD chipsets. It supports flashing stock firmware, custom ROMs and other firmware components. Number 6. Qualcomm Flash Image Loader QFIL. QFIL is a flashing tool specifically designed for Qualcomm-powered Android devices. It allows users to flash firmware, stock ROMs and other firmware components on Qualcomm-based smartphones and tablets. Xperia Flash Tool. Xperia Flash Tool, developed by Sony, is used for flashing firmware on Sony Xperia smartphones and tablets. It supports flashing stock, ROMs, custom ROMs and other firmware components. Number 8. Research Download RDA Flash Tool. Research Download is used for flashing firmware on feature phones and smartphones. Powered by RDA microelectronics chipsets. It supports flashing stock firmware, custom ROMs and other firmware components. Task 2. Perform a flashing process. Precaution. Number 1. Brand and model must be same. You can verify or net confirm your smartphone. Number 2. Never downgrade Android version of your smartphone. Number 3. Before trying anything, make a complete backup of your data in a computer. Number 4. The above tutorial only works with the stock firmware or custom ROM which comes with the scatter file in it. Number 5. Take a backup of your important data before using the smartphone flash tool, because during the flashing process, your personal data will be removed permanently. Step 1. Use a USB cable to connect your mobile device to your laptop. Make sure both devices are powered on. Step 2. Once connected, your laptop should recognize your mobile device as a storage device. Step 3. Select the files or folders you want to backup. Step 4. Copy and paste them onto your laptop's hard drive or an external storage device connected to your laptop. Step 5. After the backup process is complete, verify that your files are safely stored on your laptop or external storage device. Step 6. Press and hold the power button until the power off menu appears on the screen. Then select power off or a similar option to shut down your device. Step 7. Use your fingernail or a pry tool to carefully lift the cover away from the phone and remove the battery if it is removable. Step 8. Download the stock ROM or custom ROM software that you want to flash on your Android smartphone and copy it on your computer. Step 9. Before downloading any ROM, ensure you know the exact model of your smartphone. Step 10. Look for a trusted website or forum where ROMs are available for download. Some popular sources include XDA developers, Android forums, or the official website of your smartphone's manufacturer. Step 11. Once you have found a reputable source, navigate to the ROM section for your specific device model. Look for the ROM version that you want to install, stock or custom, and ensure it's compatible with your device. Step 12. Download and copy smartphone flash tool on your computer. Step 13. Open a command prompt or terminal window on your computer and navigate to the directory where you downloaded the firmware files. Use the ADB and fastboot commands to flash the firmware onto your device. The exact commands will depend on the firmware you are flashing, so make sure to follow the instructions provided with the firmware files. Step 14. The flashing process can take several minutes, so be patient and don't disconnect your device until it's finished. Step 15. Once the flashing process is complete, reboot your device. It may take a little longer than usual to boot up as it initializes the new firmware. Recap. In this video, so far we have discussed how to identify the flashing tools, perform a flashing process, Thanks for watching. In the last video, we learned how to identify the flashing tools and perform a flashing process. In continuation of that, in this video, we are going to learn how to flash the various brands of cell phones and smartphones. Let us discuss how to flash Android mobile using the SP Flash tool. SP Flash tool is a utility specifically designed for MediaTek MTK devices. It's used to flash firmware, custom ROMs, stock ROMs and other system files onto MTK based Android smartphones and tablets. Step 1. Before flashing your smartphone, ensure you have backed up all important data such as contacts, photos, videos and documents. Flashing can erase everything on your device. Step 2. Make sure you have the correct firmware for your specific smartphone model. Using incorrect firmware can lead to device malfunctions or bricking. Download the latest version of SP Flash tool from a trusted source and extract the files to a folder on your computer. Step 3. Open the SP Flash tool application by double-clicking on the flash_tool.exe file within the extracted folder. Step 4. In SP Flash tool, click on the Scatter Loading button and select the star.txt from the firmware folder. Step 5. Power off your smartphone completely and remove the battery if removable. Reinsert the battery if applicable, but do not power on the device. Step 6. Using a USB cable, connect your smartphone to the computer while holding down the volume down or volume up button depending on the device to enable the bootloader or download mode. Step 7. Once your smartphone is connected in download mode, click the download button in SP Flash tool to start the flashing process. The tool will begin transferring the firmware files to your smartphone. Step 8. Wait for the flashing process to complete. You will see a green circle with a download OK message in SP Flash tool once the process is successful. Step 9. Your device may automatically reboot after the flashing process is complete. This is the normal part of the process and it indicates that the new firmware is being loaded. Step 10. Once your device has rebooted, observe the boot animation. If the boot animation appears without any errors or abnormalities, it's a good indication that the firmware has been successfully flashed. Step 11. Go to your device settings and check the firmware version. It should match the version you flashed using the SP Flash tool. Additionally, verify other settings and configurations to ensure they match your preferences. Step 12. Check your data including contacts, photos, videos and documents to ensure they have not been lost or corrupted during the flashing process. Cautions: do not disconnect your MediaTek device from the computer or close the SP Flash tool until the flashing process is complete to prevent bricking. Pay close attention to any warnings or instructions provided by the SP Flash tool and ensure you are using the correct firmware and settings for your device. Recap: in this video, we have discussed how to flash Android mobile using the SP Flash tool.
Hello trainees! Today we are going to learn about the identification and use of marking and measuring and testing tools and their application. The objectives of the video are: after the session you'll be able to identify the measuring tools, use and their application. Identify the marking tools, use and their application. Let's start.
Marking of or layout is carried out to indicate the location of operation to be done and provide guidance during sequence of operations. Marking out is done with pencil or scriber, etc. Carpenter's pencil. Carpenter's pencil usually is an oval cross section. It is sharpened with a chisel. The pencil is not used for accurate work. Suitable pencil hardness for marking out on HB, H and F. Marking knife. It is made of steel fashioned to a point at one end and a sharp blade at the other end to form a cutting edge. The blade or knife is used for marking cut lines where a vertical shoulder is to be cut with a saw or chisel. The point is used for marking distances and scribing lines. Steel scriber. A steel scriber should be sharp at its point. It is used for scribing lines on which a chisel cut or a saw cut is made. The scriber should not be used as an awl. Do not strike the handle with a hammer. Marking gauge. Marking gauge is used for marking lines parallel to a face and edge. Example, gauging width and thickness. The gauge consists of square, wooden bar or beam on which wooden block or stock is sliding. This block can be fastened at any required measurement by use of a thumb screw. The gauge is set by loosing the screw and the stock is shifted to the distance required from the spur. Measurements are taken from a rule. After setting, the screw is tightened while gauging the stock is firmly held against the wood and pushed in forward direction. Mortise gauge. A mortise gauge is similar to a making gauge but with two spurs. The two spurs can be spaced at different distances and mark two parallel lines at a time. This is made of hard wood and has an adjusting screw in the end of the beam. The screw moves one of the spurs up and down or as desired. The other side of the beam is fitted with a single point as no other ordinary marking gauge. The gauge is used for marking mortises and tenons and similar joints using parallel lines. Cutting gauge. At the end of the stem, scribing knife is fixed with aid of one wedge. By loosening the wedge, the length of the knife may be increased or decreased. In broad planks, scribing marks can be marked with this gauge. Deep marks can be scribed with this cutting gauge for making grooves, rivets, and dovetails. It is possible to cut thin strips of timber and plywood up to 3 mm thick. Panel gauge. This is just like single marking gauge, but the stem and stalk are long. The length of the stem is 450 mm. In planks longer than 150 mm, scribing marks are made with the panel gauge. Trammel points. Trammel points are used for laying out larger circles and arcs. Two sliding points are fastened to a wooden batten or a steel rod at any distance required from each other by turning the knurled screw. The point is fastened to the batten or steel rod. Sometimes one of the points can be replaced by a pencil lead. Wing compass. It consists of a pair of dividers or legs made of steel. The legs are sharpened to points and at the top they are riveted or screwed. They are fixed at the required radius by means of a set screw. Uses: for setting out arcs of circles, to transfer the measurement from the steel rule to the job, to mark curves. The ruler or steel rule. It is used to measure linear lengths and draw lines. Collapsible woodwork technician's rule. It is also called zigzag rule. It consists of 10 pieces, each loosely riveted to one another. Each piece is 10 centimeters long and total length is 1 meter. Longer distances can be measured with this rule. Sometimes it contains British system measurements on the other side. Folding rule. It is also called foot rule. It has 4 folds, each of which is 6 inches or 150 millimeters long. It is joined in a plastic or metallic hinge. After taking measurements, keep the scale folded and free from dust. It is easily carried in packets. Metal clip is provided at the end of this rule to avoid wear and tear. Tape measurement rule. Tape measures are used for longer measurements. The tape is made of steel and is durable and accurate. When not in use, the tape should be kept in the box. Divisions are made in centimeters or in inches. Tape measure has a sliding end piece for inside and outside measurement. Combination set. Combination sets can be used for different types of work like layout work, measurement and checking of angles. The combination set has a protractor head, square head, center head, rule. Protractor head. The protractor head can be rotated and set to any required angle. The protractor head is used for marking and measuring angles within an accuracy of 1 degree. The spirit level attached to this is useful for setting jobs in a horizontal plane. Square head. The square head has one measuring face at 90 degrees and another at 45 degrees to the rule. It is also used to mark and check 90 degrees and 45 degrees angles. It can also be used to set workpieces on the machines and measure the depth of slots. Center head. This, along with the rule, is used for locating the center of cylindrical jobs. Calipers. Calipers are simple measuring instruments used to transfer measurements from a steel rule to objects and vice versa. Calipers are of different types depending on the type of the joint and the shape of the leg. Types of joints. The commonly used calipers are firm joint calipers and spring joint calipers.
Recap. The training session covers identifying and using, measuring, marking and testing tools in woodworking. It details various tools like woodwork technician's pencil, marking knife, steel scriber, marking gauge, Mortise gauge, cutting gauge, trammel points, wing compass, rulers, tape measurement rule and combination sets. These tools serve specific purposes in layout, measurement and angle checking for accurate woodworking. The session emphasizes proper tool usage including pencil hardness selection, sharpening techniques and practical applications such as marking mortises, scribing lines and measuring angles. Hope you understood everything taught in this session. See you in another video. Thank you and goodbye until then. Hello trainees. Today we are going to learn about identification of tools. The objectives of this video are: after the session you will be able to identify the measuring tools, use and their application. Identify the testing tools, use and their application. Let's start. Recap.
Firm joint calipers. In the case of firm joint calipers, both legs are pivoted at one end. To take the measurements of a workpiece, the caliper is opened roughly to the required size. Fine setting is done by tapping the caliper lightly on a wooden surface. Types of calipers. Outside and inside calipers are differentiated by the shape of the legs. Calipers used for outside measurements are known as outside calipers. The calipers used for internal measurements are known as inside calipers. Spring joint calipers. For this type of calipers, the legs are assembled by means of a pivot loaded with a spring. For opening and closing the caliper legs, a screw and nut are provided. Spring joint calipers have the advantage of quick setting. The setting made will not change unless the nut is turned. The size of a caliper is specified by its length, which is the distance between the pivot center and the tip of the leg. The accuracy of the measurement taken depends very much on the sense of feel or touch while measuring the job. You should get the feel when the legs are just touching the surface. Standard wire gauge. The job drawing indicate only gauge or thickness of the sheet to be used. Before starting the work, identify the correct thickness of the sheet. The thickness of the sheet is measured with the help of the standard wire gauge. These gaps or slots are of various width and correspond to certain gauge number. Gauge number is stamped on one side of each slot and on the other side. The decimal part of an inch is stamped to show the thickness of the sheet and diameter of the wire. Thickness of the sheet is checked by inserting the edge of sheet in the appropriate slot of the standard wire gauge. Wire diameter is checked by inserting the wire only in the slot and not in the circle. Higher the SWG gauge number, lesser the thickness of the sheet. Tri-square. The tri-square is a precision instrument which is used to check squareness of a surface. The accuracy of measurements by a tri-square about 0.002 mm per 100 mm length, which is accurate enough for most workshop purposes. Uses. The tri-square is used to check the flatness of the surface, to check the squareness of edge, to check the inside squareness. Mitre square. To mark 45 degrees and to test 45 degrees by mitre square is used at the end of its stock and at the cutting of the blade. It is fixed permanently by rivets. The length of its blade is 200 mm to 350 mm. There are graduations on its blade. The only difference between tri-square and mitre square is that the blade and the stock are fixed at 90 degrees in the tri-square and 45 degrees in the mitre square. Spirit level. A spirit level is used principally by the woodwork technician. It consists of a piece of wood. Common wood for spirit level is teak wood or aluminium, into which a spirit level glass is fastened horizontally and vertically. As the glass tube is not filled, a bubble always remains. When the bubble is in the center of glass, indicated by lines marked on it, the structure on which the level rests is absolutely horizontal or vertical. In some spirit level, there will be two glass tubes perpendicular to the horizontal glass tube. This will be called as plumb glass and is used to test the perpendicularity of walls and windows. Straight edge. Straight edge made of steel or wood with perfectly straight parallel edges, although sometimes has only one straight edge. Uses. For testing the straightness of surface and edges. Its length is 1500 mm to 2000 mm breadth, 50 mm to 70 mm and thickness 20 mm. T-bevel or bevel square. The T-bevel is used to test and transfer angles other than right angles. The bevel is called sliding bevel because it has an adjustable sliding blade. The blade may be locked by a wing nut or set screw. The required angle is set from a straight edge and degrees are measured against a protractor. Uses. The sliding bevel is used for laying out dovetails, side rails for chairs, chamfers, bevels, and for transferring angles from the drawing to the workpiece. The parts of the bevel square. Plumb bob. This tool consists of a solid brass or metal cylinder with a pointed end which is attached to a suspending line so that its tip is always pointing vertically down. Its upper part is small wooden block with a hole drilled in its center so that the line with the cylinder on it can be pulled up or lowered down through the hole. The diameter of the wooden block is slightly greater than the diameter of the cylinder so that the cylinder can move freely up and down without touching the workpiece. The main use of the plumb bob is a more accurate replacement for the vertical spirit level and also to transfer points down vertically in marking.
Recap. In this training session, trainees learn to identify and use measuring and testing tools. Firm joint and spring joint calipers are discussed, emphasizing their applications and proper usage. The session covers the standard wire gauge for measuring sheet thickness, the tri-square for checking squareness, the spirit level for determining horizontal and vertical alignment, the straight edge for testing straightness, the T-bevel for transferring angles, and the plumb bob for accurate vertical measurements. Each tool's purpose, usage, and key features are explained, providing comprehensive knowledge for effective tool identification and application. Hope you understood everything taught in this session. See you in another video. Thank you and goodbye. Until then. Hello trainees. Today we are going to learn the use of portable electrical drilling machines. The objectives of this video are: after the session you will be able to demonstrate the use of portable electrical drilling machines. Let's start.
The first power tool selected for the home workshop is usually the portable electric drill. It may be used freehand for drilling or fixed in a drill stand for accurate vertical drilling, or it can also be used as a power source for small bench machines. Drills can be stored into two groups based on how well their motors turn electrical power into mechanical power while keeping the right speed and force to work properly without getting too hot. In simple terms, bigger drills usually have more power, allowing them to handle lighter tasks for extended periods and operate attachments more effectively. Light-duty electric hand drill. These are available in different forms. The electric hand drill has a small electrical motor for driving the drill. On the end of the spindle, a drill chuck is mounted, which will help us fit drill bits into the drill. A handle to hold the electrical drill. Trigger switch to use the drill. Electric hand drills used for light duty will have usually a single speed. Heavy-duty electric hand drill. This drill has an additional feature by which the drill speed can be varied through a system of gears. This is particularly useful for drilling larger diameter holes for which a larger amount of torque is required. Precautions to be followed. Switch off and remove the plug from power to make adjustments. Use 3 core flexible leads and 3-pin plugs. Don't use cracked or faulty plugs which may cause leakage of current, which is very dangerous. Now, let us set the portable drilling machine. Drilling. Select a drill bit as per the size of the hole you want to drill. Insert the key into the chuck hole and rotate anti-clockwise to open the jaws. Tighten the jaws firmly by rotating the key handle clockwise. Place the drill bit on the marked point of the job. Hold the drilling machine vertically to the job. Switch on the machine and drill a hole on the marked point of the job. Give the pressure evenly while drilling to get a full depth. Using the drill. Check the size of the wooden piece using the folding rule and make sure that the length, breadth and height is 250 mm by 45 mm by 25 mm. Mark, locate the center for the hole as shown using the tri-square and folding rule. Center punch the located drill centers by a gentle tap using a light hammer. Mount the job in a bench-wise. Select the drill bit and fix on drill chuck with the chuck key. Place the drill bit on the punched mark of the drill such that the drill is vertical. Switch on the drilling machine. Drill through the hole. Give the pressure evenly while drilling to get full depth. Similarly, repeat the same process to drill other holes. Precaution: make sure the drill or bit is secured in the chuck. Remove chuck key. Allow the motor to attain full speed before commencing to drill.
Let's recap. Electric hand drills come in light and heavy duty types. The difference in them is having variable speeds and torque. We also saw that to change or fit the drill bit, use the key. Insert it into the chunk and rotate it anti-clockwise to open and clockwise close the jaw. Finally, we looked at the drilling process of keeping the electrical drill straight while drilling and following the safety procedures that come with it. Hope you understood everything taught in this session. See you in another video. Thank you and goodbye until then. Hello trainees. Today we are going to learn constructional features of hand auger, its application, different sizes of hand auger. The objectives of this video are: after the session you will be able to explain the constructional features of hand auger, list the application of hand auger, state the size of the hand auger. Let's start.
A hand auger with a twisted shank and threaded point is similar to a twist bit with a long shank and used for boring large deep holes for poles, etc. in hardwood. The hand auger is available in sizes from 6 mm to 25 mm. Parts of a hand auger: point, shank, eye hole, body, handle. Let's see each of them in detail. Point. Point in the hand auger is shaped like a screw which is responsible for cutting. Shank. It consists of an eye hole to fit a crossbar or a handle to the shank so that it gives greater leverage. Body. The portion between the screw and the shank is called the body of an auger. The parts of the body are twisted. The twisted helps to form the cutting edges, to curl the wood chips and allow these to come out. Handle. The handle is often made out of hardwood. It is fitted into the eye hole. The handle makes it easier for us to turn it, and so it gives greater leverage. Now, let's see how to use auger. Sharpen screw point at a proper angle. Hold the auger straight. Mark the drill point with center punch. Drive the handle clockwise with slow speed and high torque operation. Care and maintenance. Do not damage the threaded point. Make sure the handle is properly fitted. Now let's use the auger to make some holes. First, let's check the wooden piece size with the folding rule and make sure that the length, breadth and height of the wooden piece is 175 mm by 75 mm by 25 mm. Now, mark the locating holes using folding rule, marking gauge, tri-square as per the drawing. a wooden workpiece in vise firmly using the handle in the vise. Place the auger on one of the marked locations and turn it clockwise to make the hole. Similarly, repeat the above process to make the other hole.
Recap. In this session, we looked at what are hand augers, the parts of the hand auger which are point, shank, eye hole, body, handle, and we looked at each of them in detail, and finally we learnt how to use the hand auger. Hope you understood everything taught in this session. See you in another video. Thank you and goodbye. Until then. Hello trainees. Today we are going to learn the use of jack plane. The objectives of this video are: after the session you'll be able to set the plane for planing, set the jack plane blade, plane a wooden piece to face side and face edge, care and use of the plane. Let's first go through the job sequence and then the skill sequence. Let's start.
Job sequence. Plane the face side, face edge 120 into 25 into 250 millimeters. Set the jack plane for planing. Place the job on the workbench or hold the job on the carpenter's vise with face side up. Keep the packing piece between the job and the vise. Keep the job horizontally flat in the vise. Start planing the face side with jack plane. Check its flatness with a tri-square. Mark the face side on the job using pencil. Place the face edge up and hold it in the vise with a packing piece. Plane it along the face edge. Check its squareness and flatness of the job. Mark the face edge on the job using pencil. Gauge to the required width of 100 millimeters on both sides using the mark gauge from the face edge. Plane down the gauge lines. Test for straightness and squareness. Set the marking gauge 21 millimeters for the required thickness. Gauge to the required thickness of 21 millimeters from the face side using marking gauge on both the edges. Plane down the gauge lines. Test for flatness. A jack plane is used to plane the wood to the required dimensions with smooth surface finish. Setting and adjusting the plane blade is necessary for even and uniform cuts while planing. Step in setting. The two steps in setting the plane blade are: setting the plane blade to the required depth of cut, adjusting the cutting edge of the plane blade parallel to the plane sole or bottom face. Setting the plane blade to the required depth of cut. Hold the plane in the left hand, keeping the sole of the plane in line with your sight at a convenient distance. Turn the adjusting nut in an anti-clockwise direction to the required depth of cut until the cutting edge of the blade projects above the sole or bottom face of the plane. Adjust the plane blade parallel to the sole of the plane. Check whether the cutting edge of the blade is parallel to the bottom face of the plane. If not, move the adjusting lever gently to the left or right until it is parallel. Place the job against the bench stop. Hold the plane with the right hand, keeping the index finger on the side. Place the palm of the left hand on the toe of the plane thumb and fingers on the side. Stand near the bench with left foot forward at 70 degrees with the neck and the right foot at a convenient distance. Place the plane straight on the job and give forward strokes. At the beginning of the stroke, exert more pressure with the left hand. As the stroke proceeds, gradually the pressure by the left hand is reduced. More pressure comes to the right hand. The main objective is to keep the plane always horizontal. Release the pressure on the back stroke and merely draw the plane to the first position. Check the flatness of the surface occasionally with a tri-square or straight edge. Repeat the procedure till the surface becomes flat. Clean the job and clean the bench and tools. Precautions: do not give pressure by right hand when you start the planing. Do not put pressure by left hand at the end of the stroke. Try to plane the wood uniformly. Do not plane continuously without checking the surface. Do not take a big cut for finishing. Keep the plane when not in use on its side and not on its cutting edge. A jack plane is used to plane the wood to the required size.
Recap. To plane a wooden piece that is 120 into 25 into 250 mm, use a jack plane. Begin by securing the job in a vise, ensuring a flat and horizontal position. Plane the face side and edge, marking them with a pencil. Gauge and plane to the required width, that is 100 mm, and thickness 21 mm, using a marking gauge. Set and adjust the plane blade for even cuts, considering depth and alignment parallel to the sole. Employ proper body positioning, apply consistent pressure, and check flatness with a tri-square during planing. Repeat until the surface is flat. Hope you understood everything taught in this session. See you in another video. Goodbye and thank you until then. Hello trainees. Today we are going to learn how to use the marking gauge and Mortise gauge. The objectives of this video are: after the session, you'll be able to demonstrate the use of marking gauge and Mortise gauge. Let's start.
Perform the marking gauge and their application. The marking gauge is used to make an accurate mark parallel to the planed edge or side of a piece of wood for the purpose of obtaining the width, thickness, or depth of a groove. The marking gauge consists of spur, thumb screw, stock, beam. To use a marking gauge, hold the gauge in the left hand keeping the spur up. Hold the foot rule in the right hand and set the required distance between stock and spur. Keep the graduation of foot rule in front. Adjust the stock with the help of your left hand thumb and index finger. Now the marking gauge is set. Tighten the thumb screw. Check the measurement of accuracy. Hold the gauge stock in the right hand thumb on the top behind the spur, the forefinger on the stock and the 3 other fingers on the stem of the tool. Place one end of the piece against the bench stop and the other end in left plan. Place gauge stock in contact with the face edge of the piece and spur, touching the piece slightly in slanting position. Give forward strokes on the stock near the end. Hold the piece in your left hand and complete the gauge mark. Check the gauge mark with the foot rule. Precautions: Do not use a long spur for gauging. Do not see the distance by keeping the rule flat. Do not press the spur while gauging. Do not try to make a deep gauge. Keep the stock face rubbing against the straight edge. Do not put the spur at right angles with the face. Task 2. Perform the Mortise gauge and their application. Hold the Mortise gauge in your left hand and keeping the spur up. Hold the steel rule in the right hand and set the required distance between stock 2 spurs can be spaced at different distances and mark 2 parallel lines at a time. Keep the direction of the steel rule in front. Adjust the stock with the help of the left hand thumb and index finger. Now the Mortise gauge is set. Tighten the thumb screw to fix it in place. Hold the Mortise gauge stock with your right hand thumb on top. Place one end of the piece against the bench top and the other end in the left palm. Place gauge stock in contact with the face edge of the piece and spur, touching the piece lightly in slanting position. Give forward strokes on the stock near the end. Hold the piece in your left hand and complete the gauge marking parallel lines of tenons. Similarly, process the marked tenon line as per drawing. Check the gauge mark with steel rule.
Recap. In this session, we looked at the usage of marking and Mortise gauges in woodworking. The marking gauge, comprising a spur, thumb screw, stock, and beam, is demonstrated for making accurate parallel marks on wood surfaces. Then we learned proper gauge setup, holding techniques, and precautionary measures to ensure accuracy. The Mortise gauge is introduced for marking parallel lines on tenons with emphasis on gauge setup, correct holding, and subsequent checks using the steel rule. Hope you understood everything taught in this session. See you in another video. Thank you and goodbye until then.
नमस्कार, मैं दिव्यांशी चौहान।
नमस्कार, मैं भगवती जबनाल। आप सभी का सीएससी कड़ी की तीसरी चर्चा में आपका स्वागत करते हैं।
हमने अभी तक बात की सीएससी सेवाओं के बारे में, जिसमें त्यागी सर ने हमें सीएससी का एक ओवरव्यू दिया। साथ ही हमने बात की पीएमजी दिशा योजना के बारे में।